Now let us see an example here. A fixed mass of a gas occupies volume of 1.0 times 10 power negative 3 meter cubic at a pressure of 76 centimeter of mercury. What volume does the gas occupy at 17 degrees Celsius if it is pressure in that one of the mercury at STP? So from here we have something. A fixed mass of a gas occupies a volume. We just have V1, which now is equal to 1.0 times 10 power negative 3 meter cubic. And we have P1 is equal to 76 centimeter of mercury. Those are the data that we've been given. What volume does the gas occupy at 17 centimeter if it is pressure? If it is pressure. Now, a fixed mass of a gas occupies a volume of this one at a pressure of this one. What volume does the gas occupy at 17 degrees Celsius if the pressure is 72 of mercury? Now, from here, we have volume 1, we have P1, and then we just from the question we have V1, we are missing about V2 is equal to what? But we are just talking about the temperature. Before temperature it was 0. Do you understand? Before temperature it was what? 0. Now that is to say T1 is equal to 0 degrees Celsius, which now we add up to 273 what? Kelvin. You got that concept? And then the temperature been increased to T1, to T2 is equal now to 17 degrees Celsius. Now you add up with 273, so as you get. Now this is now, it is 290. You got my point? This is Kelvin. Now this is T1, this is T2, and this is now, it is T1. Now this is V1 and this is P1. But remember, the second pressure was given is equal to 72 centimeter of mercury. So we have all of the factors that are here. We have the first factor, we have the second factor, we have the third factor. Means volume is there, pressure there, and temperature there. Before temperature it was 273 Kelvin, that is 0 degrees Celsius. And then after the temperature was increased to 17 degrees Celsius, then when you add up to 273, you get 209. And then the pressure was changed to 72 centimeter of mercury. Now this cannot be solved by using pressure law, cannot be solved by using Boyle's law, cannot be solved by using Charles' law, because both of the factors are included. But Charles' law, Boyle's law, and pressure law, one of the factors is kept constant. But when you look at here, both of them are varying. If now both of them are varying, there is a problem. So we use general gas equation. Now from general gas equation, we definitely know P1 V1 over T1 is equal now to P1 to V2 over T2. This is what I got. Now it is from there we know we have P1. P1 now we have said it is 76 times V1, which is 1.0 times 10 power negative 3 is equal now to P2, it is 72 times V2, we don't know about it. Then we divide it then by T2. We have in 290, and T1 here we have in 273. What is missing here is V2. Now you close multiplication. Once you have closed multiplication, then V2 72 is equal now to 76 times this one times 10 power negative 3, then times 290, then here we divide it by 273 times 72, because this time this one, it is where now 72 here, this cancels out. Then you have V2 is equal, now you multiply this time this one, then you this time this one, you divide by this one. It is therefore now the volume that will be obtained is 1.12 times 10 power negative 3 meter cubic. That is the volume. Now the new volume will be equal 1.12 times 10 power negative 3, that is meter cubic. Why is it so? We have used the general gas equation because all of the factors have been used there. They are varying. If now both of the factors are varying, you must use the general gas equation. Now, if now you find the equation in such kind of the way, you use general gas equation. But if now you find there is a variation between volume and temperature, that is Charles law. If you find there is a variation between pressure and volume, that is Boyle's law. And once you find there is pressure and temperature, that is pressure law. But if now you find all the factors that are involved, we're talking about general gas equation, and here it is. That is P1 V1 over T1 is equal to P2 V2 over T2. That's how we're talking about the general gas equation.